Okay, so what I want you to see right here is if I have this fraction, it's a division problem. And it's not, some people might say, oh, look, there's a 3 and there's an x. I can cancel the 3 and the x. Not so fast. I have to worry about canceling the 3x squared with the 4 also. Oh, and also, by the way, with the 6, and also, by the way, with the 5x to the 4th. So it's not just one thing on the top. So I appreciate this example. I'm not sure how much I'm not going to do it like this at all, but it's helpful to think about when you have 3x squared on the bottom. What you mean is you have the first term divided by 3x squared, the second term divided by 3x squared, the third term divided by 3x squared, and the fourth term divided by 3x squared. Every single term on the top, every single one, not just the one you pick out that looks like it would cancel nicely. No, no, no. It's every single term. So that's important, and so I appreciate this example for that reason. Not because I want to do every one like that. That seems not my favorite way of doing it. So there's this other way that seems a lot more reasonable. And what we do is we say, how many times would the first thing go into the first thing? And we say, well, what would I need to get x squared to become 3x to the 4th? Well, I'd need a 3, and I'd need x to the second power. So when I multiply these together, I end up with what I write down here, okay? And then, I also have to say, let's see, I also have to say, it's not just that, it's also this times this, okay? And I get this right here, okay? And then, of course, it's not that alone, it's also this times this also, and I'm going to get that, okay? So it's all three things. That's a lot of color. Let me get rid of that. But it's just like a normal division other than that. When we get done, the result of our subtraction is this. And if we did our job right, there should not be anything right there, okay? Because we made these things be the same. So when I subtract them, I shouldn't get anything as a result, okay? And then I go down here and I do it again. And I say, what do I need to multiply this by to get this? And the answer is right there, 4x. 4x times x squared is 4x to the third. But then, of course, I also have to multiply it by, by that. So I get this, and I go on like I did before. I also have to multiply this by this, and so I get this. Okay. Hopefully you can see. The first thing is what determines what we're going to do, but then I also have to do it by that and that, okay? And in this case, it doesn't work out perfectly. I don't get 0 at the end. I get, oh, well, it's more than 9. I don't get just 9. I get 9 and also a negative 25x. So I take that 9 and negative 25x, and I put it on top of this. And what is that? I look back. It's the thing I divided by. So the thing I divided by goes on the bottom. If you think about, here's the thing I divided by right there. It goes on the bottom. All right, so I think I'll leave that part because that's important. Okay, so let's see here. Well, we're going to go ahead and divide this. Need to shrink this down just a bit. And we're going to say x squared. And that's all there is. So this one won't be too bad, will it? Because I don't have all those extra things. X to the 5th minus x to the 4th. And just to be in the right habit of things, I'm going to put a 0 there. Later on, I'm going to need that. This time, we'll just see what happens. But okay, so the question comes in, what do I have to do to get 5x to the 5th? Well, I know I need a 5, and I have x squared, so I'm going to need x to the 3rd. So when I multiply that together, I get 5x to the 5th, and I subtract, and I get nothing. And I bring this down, and I get a negative x to the fourth. And I say, okay, what's next? And I say, well, let's see. I'm going to need a negative x squared, right? Because then I'll have a negative x to the fourth. This is really anticlimactic after that last one. But anyway, I go on, and nothing happens. And this comes down, and that's nothing. This is nothing. So the next thing to come down here is 2x squared. And I say, what do I need? Well, all I need is a 2. So I'm going to add a 2 there. 2 times x squared. There we go. Boom. I get 0. This stuff, negative 3x. And also, might as well bring this down while I'm at it, plus 1. There's nothing I can do to the x squared to make it a negative 3x plus 1. So that's my remainder. So my answer is going to be what I have on the top so far, 5x to the third minus x squared plus 2, and then a fraction. The things that are left over, and I'm going to say plus, and I'm going to say minus 3x plus 1 over my divisor, which is x to the second power. And that's my answer. Now if you say, well, that's a negative 3x and that looks kind of funny, could I change it? Well, sure, I could change it. I could say, if you like this better, I could say it like this. There's no x that came down, huh? No x. Isn't that funny? Yeah, we skipped over the x to the third, so there was no x term. And we'll say minus, and then we can say 3x minus 1 over x squared. If you like that better, we put a minus sign out in front to take care of that first thing on the fraction. We really don't much care for this first thing in a fraction being negative. I don't know. It depends on how you want to do it. But you can see that it changes both signs on the top of the fraction. Either way is fine. Either way is fine.